systems. Hello, expert. Now, hello, I'm Evgeny Akimov. Now, this time I will be talking about ATM processing, and there will be a lot said about availability, system design principles, what makes it, different from other systems, and, other channels you guys may be more accustomed to, such as a website. So I work for Sber, and I'm the CEO of the sales network. So we get exposed a lot to our clients. We know a lot about clients. We know a lot about the client needs and expectations. So please be prepared for all that. I guess you guys, just like me, are not using cash too much. Well, because, we have NFC, we have cards, we have whatever. And still, Russians withdrew 33 billion rubles in cash in 2023 from ATMs, which is more than they did in 2022 or 2021. Now, what this means for us, as the biggest bank in this country, is that we process 250 million transactions per month and roughly 20,000 per minute. Now, I say roughly because obviously there are peak times and low times. Now, during the night, you will see naturally fewer transactions. But at the peak, it can be as many as 20,000 transactions per minute. And we're going to be talking primarily about withdrawing and depositing money in ATMs. Naturally, there are other services such as payments and transfers. They get processed, but that involves a different process I'm not going to be covering today. So, going back to how popular our channel is, well, let's just compare it to something that you guys are more accustomed to, such as, say, web or mobile applications. And you're more accustomed because, well, you've got your laptops and your smartphones with you all the time, right? Although, people love ATMs because they give you money and they make nice whirring sounds. So, ATMs are used significantly less than mobile phones. Well, the average is like 4 times a month. Like taking a phone out, using it for a minute or two is very different from, say, going to an ATM, like finding an ATM on the map and so on. And I'm saying this for a reason, As regards the architecture and the landscape, our architecture includes not just ATMs, but also other devices. So what are these devices? We also have information and payment terminals. They look like ATMs, but they don't contain cash, so that's why they're leaner. We also have ticketing or line queue management systems, and we also have various LCD screens that show various ads in the offices. They can also be part of the queue management system. Like I said, we will be talking primarily today about cash operations in ATMs. And very simply put, without naming specific systems, let's look at the key technologies. So there is ATM, there is processing inside the ATM, then it all goes to the transaction switch, which will send a particular transaction either to the bank or an SPK. Well, because since 2022, all the big companies have left the Russian market, so the only company we have left is an SPK, which does the card processing for Russians. Now, by 2024, all the systems inside the bank have been migrated to our own proprietary solutions, which are mostly based on open source technologies. Naturally, we couldn't have gone for like a small local change. We had to redo most of the design almost from scratch, from the very fundamental level. Because it's an architectural transition. We used to have a monolithic system. So naturally, we wanted to replace this monolithic system with microservices to make sure it makes sense, it's easy to manage, easy to operate. Having done that, and that happened last year, having completed our migration, we're very happy, but not for long, because the next step was, Decree 166, which said that we need to replace the foreign vendors when it comes to, the critically important elements of critically important infrastructure. What's meant by this? Well, imagine an insulin production line or like a bank-owned wiring system. Like if you are, for example, an ice cream manufacturer, maybe you're not considered, an essential piece of critical infrastructure. But, if you're a bank, there are lots of systems that you operate that fall within the purview of Decree 166. So, most systems you can see here in the schema are covered by this decree. So we migrated to a proprietary system last year, and right now we are busy migrating it from open source to vendor-substituted products, because we all know that open source software is not really freely distributed, it's still licensed, so you cannot really use it if the licensor has issues with you. This way, over the past 2 or 3 years, we have had to go through a major transformation for the second time. Why am I telling you all this? Well, because I wanted to explain why it all started. And it's actually good that we were able to redo the whole architecture, because right now, certainly, it's much easier for us to migrate it all. Like, going from OpenShift to Kubernetes is much easier. Like, you gotta change the geobalancing and so many other things, but it's still doable compared to putting onto Kubernetes something that's running on WebSphere today. Sort of goes without saying, right? So that transformation helped us. But why did we initiate this in the first place? Clients' needs are pretty simple. They say, I just need 2 buttons. I want to, withdraw my money and deposit money in the ATM. Like, repay my debt. Well, my colleagues and myself really appreciated that some ATMs had biometrics built into it. So if I don't have my card with me, I can still use the ATM. There are other products that could be important. There could be, for example, quick loans. So some features are being implemented. We want to develop our ATMs. We want to stay abreast of the times. And technologically and architecturally, ATMs have a lot of legacy built into them. Take, for example, the protocol for interaction with the host is it's quite ancient, several dozen years old, but still it's pretty reliable, and it does meet the requirements that we have for ATMs, when it comes to the way it deals with the hardware, with low-speed comms channels, because, we have ATMs in areas you can only reach with a helicopter. People also need money there. So in order to introduce new features, we had to switch from a monolithic system to something different. Because introducing such features in a monolithic system is extremely difficult, and it has serious repercussions in terms of security and dependability. So when I say microservices, it doesn't really mean our services are micro, but at least they are separate, they're modular. So we realized that we had to change our ATM network, and we wanted to embrace a new architecture, something different from the old monolithic one. So we did this even before Decree 166, and because of that, we are now making like 500 changes per quarter. And now that may sound like nothing special compared to Google or Yandex, but then we have several 100,000 devices in our ATM network, and moreover, these are sensitive operations. Like when you approach an ATM, you badly want the ATM to be up and running and perform your transaction without a glitch. For the client, it appears very simple, like 6 steps. You either press your card or you insert your card, you enter a PIN code, you select a transaction, you get your money or you deposit your money, and you get your card back. Note that unlike the remote channel, for example, there is step 5, which is very different because it's the cash step. I'm not talking about remote banking today. With a website, for example, you would be able to load a page or go one step back. You won't be lost. So you will be able to complete your transaction, and you won't suffer really. But if you've already put your money in the ATM and you see the wheel spinning, you will be really, really concerned or maybe even agitated. Because your money is already there. You can hardly wrestle it out of the ATM. And what if, it goes down? Imagine that rather than seeing this green tick, you will see, this red bubble or a notification. Now that spells doom for your money, doesn't it? So you're here, and where you deposit your money, your money will first go into the cartridges, and only after that the transaction will be registered as complete. Because only when we know that it's sort of inside the bank, we feel good about debiting it to your account. So if there is a glitch here, as a client, you will be nonplussed. At least you will have to get in touch with the bank, right? And people usually don't like that. So you imagine you go fishing to the Vladimir region. Now you need to make a small detour to withdraw your money. So you're already thinking about how you're going to fishing. So maybe you're already thinking about how you're going to be drinking a beer or whatever. And the ATM doesn't give you money. You certainly want this, little nuisance to be over as soon as possible. That's why, the system perspective of the same 6 steps is somewhat different. So the closer we get to the stages involving your money, the more handlers you will find here. I've blurred it for a reason. I just didn't want you to be, too distracted by the little detail. We're just trying to make sure that even if something goes wrong, the clients don't get agitated, and, even if we have to pay for that eventually. Now, this means that we collect roughly 30 million lines of information per day, and we put them into 22 industrial or production data machines. And, then we analyze it all, and we try to optimize it so that our clients are happy.
Здесь я рассказываю о том, почему клиенту
Now, I'm trying to tell you here why clients need more than just 2 buttons.
И все, забыть про них, запереть в ЦОДе.
Like, why can't we simply put these servers under lock in a DC? We need to introduce changes, and we want to improve customer experience.
Точно возник. Дальше мы переходим к критичности непосредственно систем.
Now let's talk about system criticality
К их надежности.
and reliability
Надежностью,
and resilience requirements. Now, availability is considered one of the key criteria here.
Mission-critical система должна...
A mission-critical system must be continuously available, at least 4 nines.
Все про 4 девятки слышали.
I think this is the standard. You should not be surprised here. These are, in fact, the requirements most systems in the banking industry will have. Particularly, if these systems support any client transactions. Now, 4 nines means the following. Your system is sort of allowed to be down, to be unavailable for no more than 53 minutes per year. So this could be planned downtime when you need to update a component, for example, some bus that's not geo-redundant. and there is unplanned downtime as well.
Допустим, у вас пошла деградация базы или что
Now,
случилось?
for example, there is some degradation in the database or something has happened to the service. I think you know exactly what I'm talking about. So 4 nines for the system means that each component of the system must have an even higher level of availability. How about 5 nines or 6 nines?
Тут тоже есть нюанс. Каждая девятка после запятой, она, конечно,
Note
добавляет
that every 9 you add
еще на порядок меньше, по сути, ну, то есть уменьшает требования к доступности на один порядок.
slashes
10 минут это
or
будет
like
5 минут в год.
adds one more degree of rigor.
Потому что
Like 5 minutes in a year is something that most clients probably won't even get to see.
вот. И на самом деле...
Now, this is like homeopathic dosage.
Да, я сейчас не говорю про конкретную реализацию, а вообще вот в целом, если вы работаете система, они доступны 5 минут в год, ну а сколько у
Now,
вас
if your system is not available for 5 minutes a year, I wonder,
с доступностью
like,
системы,
what the network availability is.
для клиента?
And the big question here is like, do the clients see the difference? Probably they don't. So if you are having some communication issues, they will still think it's the problem of the bank.
Как раз расскажу, что
Now, we have decided that 4 nines is enough for us, and we try to focus on service availability rather than specific component availability. So listed here are various activities that we perform in order to make sure that we can actually meet this 4 nines
ну, как
criterion or
да, на наш
requirements.
тираж. И то, как мы выводили нашу систему. Вот. В целом эти стратегии можно разделить на две.
Now, these strategies can be seen as either reactive or preventive.
На то,
Now, preventative ones are designed to make sure that failure does not happen at all.
нагрузочное тестирование. То есть все, что
It's like load testing or destructive testing.
как выпустили ее в продакшн,
So all those things you do to your system before you put it in production.
для этого
So everything you do like before you put it in production is usually found in this section. While reactive strategies
то есть, во-первых, вы
are designed to minimize the fallout if a fault has occurred. So you first need to identify the root causes as soon as possible,
то есть
eliminate them as soon as possible,
и
reduce the time to recovery,
влияние этих негативных факторов, этих
and also reduce the impact of these negative factors, like reduce the
Если говорить
impacted area.
двигались мы с своим тиражом, вот, то мы двигались очень аккуратно, скажу сразу.
Shown here is that we rolled it out very, very cautiously.
Мы внедрили георезерв, active,
First, we did G-Reserve, then Active, and then we were waiting for the stand-in.
После стендина мы уже
I'll cover this a bit later. So after the stand-in,
довольно быстро.
you were able to roll it out completely, very, very quickly. So it's a nice hockey stick sort of a chart here.
Либо на клюшку, да, как здесь и написано на слайде, то есть мы ее называем клюшкой, вот, потому что она...
Actually, we do call it the ice hockey stick because, or the hockey stick.
Я здесь не говорю про такие вещи, как те же rate-лимитеры или фичи-тоглы,
No,
потому
I'm not talking here about, say, rate limiters
смотрим
or other things which are naturally part of the system by design.
от масштабности и
But in terms of scale,
такого ключевого фактора, да, который мог бы заблокировать нам тираж, вот, мы
and
выделяем
the key factor that could stand in the way of us, rolling it out, I've identified 3 key elements, the ones that are listed in the legend.
Я напомню, что георезерв — это
I should probably remind you that what we call Geo-Reserve is like the second independent application counter where balancing should not happen if everything goes according to the plan. So if something happens to the primary counter, then the load will go towards the second counter.
Конечно,
So
это
it's like the backup system.
отказоустойчиво и надежно, поэтому, конечно, сразу
Such systems are certainly very
распределяется более равномерно.
reliable and fault tolerant. That's why we went to active pretty quickly.
Между ними, но плюс-минус. Там могут
So load is spread here pretty evenly, not ideally, but it's still done in round-robin order. So if one of the counters is disconnected, the client won't suffer at all,
нагрузка переключается на второе плечо,
because
которое
all the load will go towards the second counter,
да, то есть оно имеет
which is designed to support it.
X, там, ну, X сколько-то, неважно.
It actually
Того,
has
что оно должно держать.
a certain performance slack. It's not just X2.
У нас
it's designed to support apparently even more than that. Now, think about, say, New Year. During New Year, the load on the system goes up by 50%, so you should be able to support that as well. So it would appear it's a pretty nice arrangement, and it should be enough, but it's not. It's not, because it doesn't really defend us from issues with the general components you can see in the center, such as a database.
Ого, ветер поднялся. То есть у нас,
Is it windy here?
понятно, стоят ли сервисы, вот, и они имеют консистентное хранилище по центру.
So we have this consistent storage over there in the center. So if something happens to the database, then none of the two counters is working, which is bad. So naturally, it's not just, a single storage. Naturally, it's redundant, it's distributed, it's a cluster, and still, we realized pretty quickly that we cannot do the rollout with this. So we decided to change it for this stand-in kind of arrangement. Now, stand-in is kind of a backup for the primary counter. Now, the primary counter, just like the stand-in, has apparently the storage as well as the whole counter. So it can easily it can support, the whole fleet of devices or machines that we have. So the level of redundancy here is X. I should not probably tell you the specific number several times, okay? Now, I mentioned rate limiters previously. So there are rate limiters for the external system shown here on the right, which manage the incoming load. So something may happen, and although we may be sending the regular number of, say, calls, we may be getting an increased number of responses. This has happened. Like, we can easily get over 100 responses to a single call. So we do need a rate limiter here, because otherwise the system may go down.
И больше, чем одно соединение, одно устройство тоже установить не может.
So a single device cannot establish more than one connection, and this is by design, this is part of the protocol. So inside the system, and we have a map like this showing that inside the system there is also a kind of a gap that can protect the core services. If there is some sort of freak overflow happening. So stand-in has enabled us to do, the proper kind of redundancy for the whole system, and we felt much better. And we were able to complete the rollout process. No redundancy, backup measure. So, see the blue gateway on the left. So with mathematical expectation of 30 seconds, it will change every 30 seconds, which means that we spend 30 seconds to 60 seconds to go to stand-in, which means that every device gets a new route and it gets connected to the stand-in counter. Now, the gateway you see in the center here, naturally, it's backed up as well. And it is the one that makes the decision which counter will be tapped. Is it the primary or the stand-in? So we went through several stages here. The first one was manual, like fully manual. So it's effectively a job that merges a pre-prepared pull request that will manage the balancing at the level of the gateway I previously showed. So it's simple, it's reliable, and we used it back when we implemented stand-in. And then, pretty quickly, we transitioned to switching through UI. So our operator has this large red button which puts the system in stand-in mode.
Мы, когда внедрили вот как раз этот UI, мы сразу провели аварийное учение и сразу стали...
When we implemented UI, we did a drill.
Зачем-то сделали контроль второй рукой, потому что вроде операция такая.
And we initially thought that okay, it's a pretty responsible operation, like a pretty critical operation. After all, it has a large red button, so we thought that okay, it should only work if we have a confirmation by somebody else. So like 2 hands required, and that takes like 30 seconds. seconds. And I said, well, we perform like 20,000 transactions per minute, so we decided to dispense with the second-hand rule. And the second important observation was that although we have this monitoring, as you can see in the slide, which kind of shows that, apparently it's time for us to go into stand-in, but the human factor is still there. So the system administrator or system engineer will sort of wait for the system to rebound. So he may be thinking, okay, if I wait for 10 seconds more, things will go back to normal. Or will they? Just consider the losses we can sustain. Therefore, the next stage is that there will be automated switch to stand-in. If, for example, we are seeing a decrease in number of transactions or an increase in the number of errors, given that, the number of commits to the database stays the same. We're not there yet, because take this criterion, for example, like a decrease in the number of transactions. Our offices close at 9 p.m., and this is when the number of transactions dramatically drops. Does it mean we need to go to stand-in mode? No, it doesn't. So rather than doing until 9:30, but we should also compare it to the data we had for the same period of time, like a week ago and a month ago and so on. So we had to first analyze it all before we were able to initiate our transition to stage 3 and automated switch to stand-in. Also, please remember that the growth in the number of mistakes when you commit, make your commits to the database may be related to your own system, or maybe to your partner systems. Maybe something's wrong with the communications channels. And, just going into stand-in every time doesn't sound good. However, it does give you more reliability. So there is one more reason why we chose not to do this automated transition a bit later, because doing this switch costs us something. So there is like a normal distribution of transactions, and as we go to stand-in, there will be a dip. We're not really losing anything, but the clients for like 30 seconds will not be able to perform their transactions. Like the second time they try the same transaction, they will be successful. Clients don't lose anything. This is like postponed demand. But we understand that clients may dislike it, so we're trying to avoid that. So I previously said that, when you part with your money in the ATM, you don't want any uncertainty. So it can happen that, we go to stand-in mode once you've inserted your cash into the ATM. I previously showed in the schema that there is replication happening between stand-in and the primary counter. Naturally, this replication is happening online, and I'm not saying it's ideal. Like, hypothetically, what can happen is that in the new counter, you will not be able to find the transaction that was initiated in the old counter. This can technically happen. Now, the so-called second phase of the transaction, like you've inserted your money, the bank knows the money is in the cartridge. Only after that, it will register the transaction as complete. Which means that, well, there may be some, terminations here. Remember what I said previously about 4 nines and being proactive? We want the whole service to be easy to understand and to create seamless experience. So going back to 20K transactions per minute, max number of calls we got as we moved to stand-in was 36. And these are not financial claims, These are like calls clients make, they try a transaction, and the second time it succeeded, but, they're still feeling unhappy. So 36 calls per 20,000 transactions. Now, that's pretty good, if you ask me.
Так вот, как же происходит докат тех операций, которые мы прерываем в случае, когда
how do we go about those transactions that seem to be suspended during the standard process. Now let's make this schematic a bit more complex. So I'm showing here ATM monitoring and reconciliation. Reconciliation is shown against the pink background. So there is a system which controls how transactions go through all the stages. Think of it as an octopus or something, because it will be checking in the monitoring system if there have been any failures, if some money has not gone through a particular transaction. For example, you've put your money into the ATM, the transaction has been initiated, but it's not showing in the processing database, meaning it got lost somewhere. In this case, this system will make sure the transaction is perfectly completed. So this is like a kind of a backup processing system running side by side with the main one. So it's indeed a backup processing system, and it's running on separate servers.
Для клиента это выглядит следующим образом, то есть
That's what it looks like for the client.
вносите, начинаете беспокоиться, потому что случился,
Now you put your money in the ATM, then we do the stand-in, you get uneasy, then in the next 30 to 60 seconds, you get an SMS telling you your money has been successfully deposited, so you shouldn't worry.
Варианты, когда там происходят какие-то замятия денег, что-то еще.
A more complex case where, for example, money gets kind of wrinkled in the cartridge, but that's a technical issue, so I won't talk about it. Now, we also have AI running there, which makes decisions about, how much money could have been deposited here and what to do about it. That's actually an interesting discussion. We don't have time for that. Now, I previously mentioned reactive strategies.
Или у вас может быть насколько угодно классный дизайн системы, она может быть очень
We can have an elegantly designed system.
И мы точно будем ей гордиться. Ну, мы же ее создали.
And we will be very proud of it. After all, we designed it, didn't we? At the same time, we are never 100% secure, because besides the system itself, there is also infrastructure, such as comms channels.
Я тоже много про клиента говорю, ровно потому что, мы как инженеры любим говорить, у меня проблем нет, у меня система работает.
Often say, I don't have a problem. My system is up and running. It's, people updated policies on the load balancer, and something must have happened to the routing table, but clients don't care, because, they end up being hurt. So you certainly know, some of the younger people probably do not recognize the floppy disk drive. Now, he has this lid, which kind of flops, that's why it's called floppy.
Что-то еще. Вот, допустим.
Then, other things can do the same, kind of flopping. In the active-active layout,
короче, мы с вами никуда не уйдем.
Guys, apparently we're staying here because it sounds like
вот. В том
like it's not just a rain, it's shower outside. So in the active contra, there is a geo-backed up high availability cluster. And I previously said it would not be enough. That's why we decided to switch to stand-in. Theoretically, it is possible that something happens to this cluster. In 99.9% of cases, hardware issues are those of storage systems.
То есть мы переезжаем,
It could be some software issues, but if we're talking about hardware issues, this is storage.
У нас на другой инстанс, и все будет хорошо. Но не всегда, потому что может быть проблемы не в СХД, это прям...
However, there could be other problems as well.
Адаптере ввода-вывода. То есть мы знаем...
For example, it could be input-output adapter issues, like we all know how our servers interact with storage systems. So unlike laptops or desktops, they go through the switch to connect to the storage through the I/O adapter, which is effectively a network interface which enables the servers to connect over fiber optic. So, if an adapter starts flopping, transactions will fluctuate. So, for example, if the number of commits to the database goes down, it's easy. We just switch to different contra, but if it's like comb-shaped, it's not entirely clear what to do. That's why we need the stand-in contra as a reactive strategy. In this case, we just go to different virtualization cluster, and everything seems to be nice while it's running there. The engineers will go in to look what has happened. So showing here is the stand-in. So you can see the replication happening there. And like I said, it's not ideal. Sometimes, theoretically, we may have to interrupt some transactions. Now, we decided that stand-in was not good enough for us because we do want to have zero downtime. So, we want to go to stand-in, we want to do our implementations and other things without having any impact on the availability of our system and our service. So this is where another technology will come in handy, together with caching. I'm talking about sharding. Actually, I believed until the last moment that we would be able to do without sharding. Now imagine you have a database of 200 million clients and you distribute it into shards, and you have standalone applications running for every shard. And this way, every client kind of lives in his own realm. Well, that's not our case because we don't have too many devices, only several, dozen, thousands. So you don't need shards that much. But we decided to do sharding in order to reduce our attack surface. And we are completing this transition now. I'm showing 4 contras here just for illustrative purposes. We could have as many as we want, and each of them can take in the traffic from the whole fleet. Note that they're all equal. Now, in the previous arrangement, like we have a primary and stand-in is not activated until something happens to the primary contra, but here all the 4 contras are working at the same time. And traffic is distributed between them all the time. And, there is a specific caching mechanism used in order to distribute the traffic. So if one of the 4 shards goes offline, now it will be distributed, and all of them naturally have the enough capacity to maintain the full traffic. Which means that, if everything goes to the dogs, just a single shard can be considered stand-in. And it could be used in greenfield and brownfield installations. So we can, for example, send specific traffic through the load balancer, I guess, to a particular shard, which is convenient. Now, switching between shards will happen sort of instantaneously, because we do caching there as well, like several levels of caching. Now, there is application level caching, namespace level caching, the whole shard. Next one is project-wide caching, L2. And there is also backup at the storage level. So project-level caching is like Ignite. And Ignite works faster than a DBMS. But in terms of reliability, it's not ideal, but let's not open this can of worms now. So in-memory backup is certainly an important thing to do. Works fast, and still backups are required. So at least one of these levels should work, right? And this means that switching between shards will be free, quote-unquote. Now imagine that if one of the shards stops getting traffic, another shard will simply take the cache. Will take the data from this first shard from the cache. So we believe that we won't be losing anything here. Now, talking about preventative strategies, we should also consider the production processes as such. Remember, I mentioned 500 changes previously, and we do not roll them out just like that. the canary method? No.
Закончится, мы так точно
Well, because we are exposing our clients to them. So we first want to double check everything. Every change goes through all the contracts, including dev for developers. ST is a collection of developers,
разные компоненты уже собирать.
so they can test different components together. IFT, where other systems get involved. So this is a consistent counter
Со всех систем. Дальше
where we have, benches representing all the systems.
контуром, где представлены все системы, но он
Now, LT is another counter,
с точки зрения
and it's already like production
которые на IFT, ну,
in
просто
terms of balancing and other modules which are not used at the IFT stage. I'm talking,
ровно потому что он там не нужен. Вот.
for example, here about hardware encryption module.
Перед промом точно надо проверить вообще.
But before production, obviously, you want to check everything.
Ну и дальше с ПСИ это попадает на прод.
And then, from UAT, it goes to prod.
Я говорил, сразу на
And then it's piloted in waves, just like I showed previously. We never roll out 100% in one go. We start slow, we do pilots, and then we slowly expand.
И ход фикс.
Now we have two separate counters. One is load testing, and the other is hotfix. So we do load testing on a regular basis. We are big fans of that.
Немножко другие ошибки, не те, которые там.
And naturally, it's designed to identify some mistakes, but not the ones that these countries are good at identifying.
И нагрузочное тестирование мы проводим, как правило, на заглушках, потому что
So load testing, for example,
доступность смежной системы 24 часа довольно сложно. Вот. В любом
it's pretty difficult to ensure that an adjacent system is available 24 hours. So we usually do load testing during the plant downtime.
Он нужен для того, чтобы если вдруг в теории
So hotfix is running the current version of the production system, and we need it in case something goes wrong or like an incident hits us,
вот, есть уже готовый контур,
particularly client-side incident.
повторить, проверить.
So we have a counter where we can reproduce this situation and test a particular fix there, because all the other counters are busy with the other configurations. So
Ну, в принципе, все.
in the hotfix, we are running the same version as we're running in production. I think you have something similar.
Повторяю, что да, у нас
So it's probably a bit repetitive. I'm just trying to show that, we have a very similar arrangement, and we believe that's the only way to do it if you're a large bank.
у нас дальше планы. Ну, дальше будет
What are
в сторону
our future plans?
увеличения.
We will be considering increasing our uptime,
Всегда доступен. Вот. Но тем не менее, нет
although,
совершенства.
in mundane terms, it's already eternally available,
Варианты, как
but there is always room for improvement.
Спасибо, что
Thank you very much
воскресный вечер были с нами. Я
for
постарался
spending this evening, Sunday evening.